So today we are going to talk about, okay, let me check this recording. Yes, it's going on. So today we are going to talk about properties of convolution. Very easy topic. So there are three properties: commutative property, distributive property, and associative property. So what is commutative property? Commutative property means, let's suppose if you have 2 multiply 3, what is the answer? 6. Then 3 multiply 2 is also 6. This is called commutative property. So this convolution follows this property. xt convolution ht is equal to ht convolution xt. This is for continuous time system, and xn convolution hn is equal to hn convolution xn. This is for discrete time LTI system. Next one, distributive property. Distributive means, if you talk about this word in Arabic, I think this is taqsim, something like that. Let's suppose if I have 2 multiply 3 plus 4, what is the answer of this? This is 7 and this is 14. Okay, I can do like this also. 2 multiply 3 plus 2 plus 4. What is the answer? 6 plus 8, 14. So you have distributed this multiply with 3 and then multiply with 4. This is called distributive property. So convolution follows this property. Now you can see xt convolution, then h1t plus h2t. So you have distributed xt and multiplication, this all you can see with h1, okay, and the plus sign, then xt convolution h2t. This is for continuous time LTI system, and same for the discrete time LTI system. Next property, commutative property. Sorry, associative property. Next one is associative property. Associate means something like grouping. Okay, something like grouping. Let's I show you with the help of an example here. Let's suppose I have 2 multiply 3. What is the answer of it? The answer of 6 multiply 3, 18. Okay, and I can write like this also, 3 multi, oh, I do one change here. I take another example. 2 multiply 3 multiply 4. Now it is more good. Then what is the answer? 12 and multiply to 24 is equal to, if I do like this, 2 multiply 3 multiply 4. Then what is the answer? 6 multiply 4, 24. So both the answer are same. In first this in this equation, 3 and 4 are associated, and here 2 and 3 numbers, these two numbers are associated. So convolution follows associative property, just like xt convolution h1t convolution h2t. So first these two are associated, then we can associate xt convolution h1t. Okay, this is for continuous time LTI system, and this is for discrete time LTI system. Next one, properties of LTI system. Now properties of LTI system with or without memory, invertibility, causality, stability, and this one, unit step response. I will tell you later on what is this unit step response. Now these four properties you have studied in chapter number 4, if you remember, properties of a system. But there is a difference here. Definition is same, system with or without memory. The definition you have studied in chapter number 4 is same in chapter number 5 also. Definition is same for all these four. So what you have is learned in chapter number 4, same you can write in chapter number 5. Only definition, I am talking about definition. System with memory and without memory, the definition is same for the LTI system with memory and without memory, but there is some change, I tell you. Now first property, First property is what? System with and without memory. A system is memoryless if its output at any time depends only on the value of its input at the same time. Means output doesn't depend on past and future. So it means system is without memory. So you have studied this definition in chapter number 1. So, but for the LTI system, this equation is important. You have to write this equation. The impulse response should be 0 for t not equal to 0. This you have to remember. This is for continuous time system. Same for the discrete time system. Same for the discrete time system, you can see here. Same, Hn is equal to 0 for n not equal to 0. Okay, this is for discrete time LTI system. Now, invertible. What is invertible? We have seen that a system S is invertible. If a system is invertible, if and only if there exists an inverse system, means a system is called invertible if and only if the x of the system is present. Okay, inverse means opposite system is present, such that S inverse multiply S produce an output equal to the input of the first system. Means the output of this and the input of the first system both are same. Okay, as I have told you in the last chapter also, let's suppose I have a system S1 and I have a system S2. So this system do multiplication, and here is, let's suppose input is 4. So what is the output? Output is 8, and this system do division by 2. Now what is the output here? 4. So the input to first system and the output from second system both are same. So this system is inverse. Both are opposite to each other. We can say this system and this system both are opposite to each other. So this is the basic idea, and the important thing is you have to remember this. So impulse response of this system and impulse response, let's suppose of this system is H, and convolution impulse response of this system is H1t. If you take the convolution of both the impulse response, then answer should be delta signal. Delta means 1. Delta signal. Same here for the discrete. If you take the convolution of two systems and they are invertible, then this is del n. This is for discrete time. Next property, causality. A system is called the causal if the output depends only on the present and past. You know about it, this definition, not the future input. Okay, the output depends on past and present input, not the future input. And this is the condition. Ht is equal to 0 for t less than 0. For, or you can semicolon, both are same. Okay, you have to remember impulse response should be 0 for t less than 0. Last property is stability. What is stability? Stability means if you give a system, if you give bounded input and the system produce bounded output, then we say the system is stable. The system is stable. So a system is stable if every bounded input produces a bounded output. So this is the definition. What is the equation for LTI system? The impulse response should be less than infinity. Okay, the impulse response should be less than infinity. This is the equation for LTI system, and this is for the discrete time. This is for the discrete time. Okay, the last and this property, what this property says. Now we have seen in the previous chapter also, and in the starting of this chapter, if the input is delta signal, for the LTI system, then the output is called HT, impulse response. Now, yeah, if you remember in chapter number 2, I have told you about this signal. This is a spatial signal, and what's its name? Unit impulse. Now, same system, LTI system I have. Now, the input to this system is UT. UT is what? A spatial signal. What its name? Its name is unit step. I am writing here unit step signal. When unit step signal go inside the LTI system, now the output is also standard, that is called ST. This ST is called impulse unit step response. Okay, so this is the here. Unit step response is defined as ST for continuous time LTI system and SN for discrete time LTI system when the input is UT. So you have to remember this one. What is a unit step response? Unit step response is the output of an LTI system when the input is unit step signal. This is the end of your chapter number 5. In next video, we will see chapter number 6. Thank you.